Hello children, welcome back to chemistry class. Today I am here with another topic, dipole forces. Dipole forces. So it is a type of force, means van der Waal force. It is a type of van der Waal force. That one type of this we have already discussed, that was the dispersion force or London force. Okay. So you might be clear here that dispersion force and London force, I have shared one story with you, but it has also one story. I would like to say that if you are understanding with the help of a story, it would be easy for you. Like that, I shared in that for London force. What in London force? What I said? What story I shared there? I shared one story there. Do you remember? If you do not remember, just you watch there. But another story is behind this is dipole interaction. Means this story is related to like that only. What is that? Just sort of see here. If two boys are there, what? Two boys are there. In that, both are studying. Two boys are there, and both are studying. Okay. Two boys are there, both are studying itself. They are internally inspired, they are studying and they want a good post. For that, they are interacting to each other. They are interacting to each other. So their knowledge will be updated. Their knowledge will be updated means like two students are there and both are studying. Both are studying means they are studying, but by seeing each other. By seeing each other, they are studying much more. They are studying much more means our interaction is being developed. When one boy say he is studying, then other is say he is studying. Means if A, just I would like to say A and B, both are studying here. Both are studying, and what would you get here? Both are studying here. So they are making some bonding. They are making some bonding means by seeing others they are studying. Means if A has seen B is studying, so he goes and study more, and then if B seen he is studying, so he goes and study more. So there will be a strong bonding. There will be strong bonding. So this story is related to like that. So let us begin our topic without being delay. Here topic is that dipole force. Means dipole force means this type of force is observed in the molecule half permanent dipole. Molecule half permanent dipoles means this type of interaction or this type of force is observed when molecules are permanent dipole. How does it happen? Let us see here. So in this, what is happening here, just I would like to explain here. Just you see in this, if that means molecules are permanent, molecules have permanent dipole. So you might be knowing if molecule is having permanent dipole, there will develop a charge. So one portion of that is carrying negative charge and other portion is there positive charge. So here I have taken HCl as it is here. I have taken two molecules of HCl, A, and these are the students A and B. And what we observe here, let us see what we observe here. You might be knowing HCl is polar molecule, so it has developed charge. So negative charge to that side, right side, and positive charge to this side. So this molecule has permanent dipole moment. What you observe, I am taking another molecule like that HCl, C molecule we have taken, these two molecules we have taken. So what is happening in this, charge is developed here, delta plus charge and delta minus charge, and this charge is always less than the unit charge. So what is the unit charge? Unit charge you might be knowing 1.6 into 10 to the power minus 19 coulomb. So this charge will be always lesser than unit charge. Just so here. So this portion means negative portion of one molecule attracts the positive portion of other molecule, and interaction developed between the molecule, and this is the dipole force. This is the dipole force Just one more time, also see here. This type of force is also molecules having permanent dipole. Molecules having permanent dipole. It means the positive portion of one molecule is interacting with negative portion of other molecule. A force is developed in such molecules, and that force is called dipole force. Dipole force. Just come to the point. Dipole force means molecules having permanent dipole and a force developed between them in oppositely charged portion of the molecule is known as dipole forces. Dipole forces. Just want to see here. Are you getting my point? Yes, you might be getting my point. I tried here. Just you see here what is happening here. Distribution of electron cloud in HCl, a polar molecule. So it is a polar molecule, so electron distribution will not be same. Electron density will be higher towards more electronegative atom. So in a molecule that is more electronegative atom, and electron density is more that side. In that second one, just as electron density is more side. So positive charge and negative charge develop, and this is the Greek word, and its value is always lesser than 1 unit, because this is not 1 unit charge. Delta charge means we can say it is a small charge developed, so it is always lesser than the 1 unit charge, and negative portion of this is being attracted by positive portion of this, and a force developed that is known as dipole force. What type of molecules shows this type of interaction? Molecules having permanent dipole, they show dipole interaction. Let us see here. So dipole interaction between two HCl molecules. I have shown dipole interaction between two HCl molecules. Let us see some more points here. In which type of molecule it has been observed? In which type of molecule it has been observed? So let us see here, students. The molecules having permanent dipole. What I told, both students are studying and they are making interaction by seeing each other. Okay, so the molecules having permanent dipole, and just to remember, molecules having permanent dipole. This dipole force is stronger than the London force but weaker than the ionic force, because just you see, on ions there is unit charge. On ions there will be unit charge, so this force is weaker than the ionic charged compound, and more than the London force or dispersion force. Just all of us here, this force here. Okay, you can observe here. Only here, why is it? Because only partial charges are involved. Means in this interaction only partial charges are involved, not a full charge. Means that is not a unit charge. Unit charge value is that. Okay, so this value is lesser than that. So in this case only partial charges are involved. Because of that, this force is weaker than the ion interaction, but is stronger than the London force. Why is it stronger than the London force? You might have seen in that, like this charge was not developed in that. Like this charge was not developed, just for little polarization took place in that case. Little polarization took place in that, and if we see here, little polarization took place in that. Not this much charge developed in. So if we talk here, in this case, means dipole force, it is also molecules having permanent dipole. Okay, here the attractive force decrease with increase of a distance between dipole. As the distance here, as the distance between this increasing, that decrease the dipole for interaction. Okay, and the interaction energy means interaction energy. You know that if any force is being formed and any attraction and any bond is being formed, some energy is being released. So attraction energy, let us see here, interaction energy is inversely proportional 1 upon r cube. 1 upon r cube. In this case, in normal case, when molecule is rotating, so in that case 1 upon r power 6 between rotating molecules. Between rotating, just this point I would like to clear here. If molecules are this, molecules are this like this. So in this case, interaction energy is inversely proportional upon power 3. But if molecules are rotating like this, in that case interaction energy is inversely proportional to the distance between them. Here, where r is the distance between polar molecules. Just want to see where r is the distance between polar molecules. So one more time, I would like to explain here what type of molecule shows. This type of interaction is shown by the molecules having permanent dipole, and one portion of molecule is being attracted by other portion of next molecule, because charge have developed an interaction created. This is called dipole interaction force. What I told, I would like to revise it here. Story. Yeah, two students are there and they are studying, they are interacting by seeing each other. Means if one A is studying more, then B is going there and studying more. If B is studying more and A is going and studying there, means interaction. They are internally inspired, but by seeing they are interacting, means they are by seeing to each other they are studying much more. So in that, what I said means, in that, do you remember here that is story what I told in dipole London force or dispersal force? Do you remember here? So I would like to tell, I told one story in there also. What was the story? One boy, there were two friends. They were doing all the work, but they were not studying. But sometimes something happened to A. And A has started studying. By seeing him, B has started studying. Means an interaction created. That was the interaction. London force or dispersal force. Okay, and force is appearing by seeing others there. But in this, both are internally inspired and studying and making interaction. So in this case, if we talk here, in this case, we will observe what is this force is more effective. This force is more effective than the dispersal force or London force. Okay, students. So students, next is dipole-induced dipole force. Dipole-induced dipole force here. So I would like to share one more story with you. One more story. What is that? You might be thinking why I am sharing a story with you. So by this concept you can understand it in better way, and you may be adopting very nicely this one. So let us see, students, here. So what you observe in that case is here, two boys are there. Just also see here, two boys, A and B are there. A and B are there. There are two boys, A and B. What is that? A boy is studying much more. Studying much more. Yes, just all of listen here. A is studying much more, but B is not studying now. What happens when B came in contact of A? When B came in contact of A, effect of this is being produced to him. Effect of this is being produced to him. By seeing him, he also started studying. B also started studying, and they formed a force between them. And this is the story of this. What is this? Is the story of this. So let us see how can we say that two boys are related to this here. Let us see here. Means here, dipole-induced dipole force means, in this it has been observed that one molecule has permanent dipole, and that induce dipole in other molecule, and they form a force that is called dipole-induced dipole force. Means one molecule has permanent dipole moment and other molecule is being attracted or dipole is being produced in the next molecule by deforming the electrical neutrality of next molecule. Let us see here by diagram, it will be clear here. So just of see here what I am telling here. This is the molecule. This has permanent dipole. Permanent dipole. This molecule has permanent dipole. What you observe? But that is non-polar, means electrically neutral. So what happening when they are in close, or when these molecules are brought closer? So what is happening? Just sort of see here. This negative portion of that molecule, this negative portion of this molecule attract the positive portion of that molecule. Listen here. This negative portion of molecule attract the positive portion of other molecules, and polarity is produced in the molecule. Polarity is produced in the molecule, and this is the reason they interact. One more time, this is the polar molecule, that is non-polar molecule, that is electrical neutral molecule, and this is polar molecule, and polar ends of this molecule attract the negative portion, not positive portion of that molecule, and polarity is produced in this molecule. And when polarity produced, they interact, they develop one force, and that is known as dipole induced. Means what is? Just sort of see, dipole induced dipole force means this molecule has induced dipole in that, this molecule has induced dipole in that, and developed one force between positively and negatively charged portion of both molecule, and this is known as dipole induced dipole forces. Dipole induced dipole forces. One more time, just output all of see here. You see, this is the molecule, this is polar molecule, that is non-polar molecule. Polar molecule is charge developed. So negative portion of this molecule attract the positive portion of that molecule, and polarity is produced due to this. So what we say, dipole induced. Who has induced dipole? This molecule has induced dipole in that. And when dipole will be induced in next molecule, they will attract. When dipole is created in the molecule, positive and negative, or we can say opposite portion, oppositely charged, will be attracted, and a force is developed, and that force is known as dipole induced dipole forces. So let us see how does it is being developed. Just sort of see here. Permanent dipole in this, no dipole, non-polar molecule. This portion of molecule has attracted the oppositely charged portion of that molecule, and it has induced the forces. And if it has induced the dipole, and the oppositely charged portion of the molecules are developing a force, and that is known as dipole induced dipole forces. So let us here induced dipole in a non-polar molecule. Here non-polar, non-dipole, but due to this dipole is created, so we can say induced dipole in this here. And here what is this? Dipole induced dipole interaction between permanent dipole and induced dipole. Just look here, permanent dipole and induced dipole. What are you getting that? Just sort of see, students, here what is the methods here? Just sort of see here, dipole induced dipole interaction. Induced dipole interaction took place due to inducing dipole in non-polar molecule. So say dipole induced dipole interaction between permanent dipole and induced dipole. When interaction will take place? When the dipole is induced in next molecule. Let us see here, come to the point, students. Here let us see here, this type of attraction forces operate between the polar molecules and the non-polar molecules. Polar molecules and non-polar molecules. When it will be developed, this force here, just sort of say, polar molecule deforms the electrical neutrality. Polar molecule deforms the electrical neutrality electrical neutrality and produces dipole by attracting opposite charge of other molecule. Yes, means dipole is produced by the molecule having permanent dipole. How is it produced? By attracting the oppositely charge of that. If this is negatively, so it would attract the positive portion of this, and dipole will be induced in this molecule also, and they will attract. And here if we talk about interaction energy is inversely proportional 1 to the inversely proportional r power 6. Dipole, just what we see here, interaction energy is inversely proportional 1 upon r power 6, or we can say inversely proportional to r power 6. And induced dipole moment, other points you have to remember here. Induced dipole moment is permanent dipole, means induced dipole moment is directly related to induced dipole moment. Induced dipole moment is directly related to permanent dipole, means what type of dipole is being having by the polar molecules will decide the dipole moment in the non-polar molecule. It means if one molecule having the permanent dipole is strong permanent dipole, so in this molecule there will be strong permanent dipole or a strong induced dipole. Sorry, there will be strong induced dipole, and induced dipole directly proportional to polarizability of the neutral molecule. Polarizability of the neutral molecule. So here I would like to share here that it has been observed that if we see in this case, what is in some time, just you may see London force also may be present in this London force little bit, and dipole interaction force also, because dipole created, and this effect also observed. So I said 3 story. One more time I would like to revise this story, so by that you can understand here. So let us see, students, what was the story. So let me explain one more time here. In this, what was the story? A means 2 students are there. A is studying much more, but B is not studying at all. A is studying much more, B is not studying at all. But when B came in contact of A, by seeing him, or A said, man, you are not studying, so don't come with me. So B has started, he wants to live with him. B wants to live with him, and when he has started studying, and how much he is studying, that much he has also started studying, and one force created, that force is dipole induced dipole forces. So I think you might have understood what I would like to tell here. Just you see this observation, which this type of force is observed, a molecule having permanent dipole moment and non-polar, and the permanent dipole moment molecule induced dipole in the non-polar molecule, and a force is developed that is called dipole induced dipole forces. And I have said 3 story. First for dispersion force, and second for dipole forces, and third is dipole induced dipole forces. So only 2 minutes I will take, then you can understand it better. Okay. So students, we have discussed this. So I have said one story to understand the van der Waal forces, all 3 types of forces. So you can search in my channel, and my channel name is this Chemistry with Santosh Pandey. Sir, you can subscribe if you want, and you can watch that diagrammatically explanation of van der Waal forces. Okay, thank you so much, students. Keep watching my videos for further updating you content with me.